Good morning, ma'am.
Good morning, sir.
Few seconds, ma'am. Most of
Good
the
morning, sir.
people have joined up. I
Sure, sir.
Good morning, sir. Hello.
students, please mute
Good
your
morning, sir.
please be mute your microphone, students. Okay. Good morning, Sudha ma'am. We shall start the program, ma'am.
Yes, sir.
Okay. Good morning to one and all present here. We warm welcome to our chairman and the respected principal and the respected HODs and the respected Triple E and the EC department HODs and the mechatronics department HOD and various faculty members for the one fine uh, workshop on virtual lab, introduction to virtual lab. So it's exclusive for Triple E, electronics and communication and in your mechatronics department. It's a wonderful opportunity to you. So I once again welcome our NIT Surathkal virtual lab team. Especially I warm welcome to Shraddha and our team. And because of we last year we also arranged one of the virtual lab. So again we do the exclusive for the Triple E and the EC student for the separate section for the virtual lab. So we welcome ma'am, and also now the session is yours, ma'am. Thank you, ma'am.
Okay, sir. Thank you.
Good morning all. Myself Vismaya, working as Senior Research Fellow here in Center for System Design at NITK, Surathkal. On behalf of the Virtual Lab team, I welcome the Principal, the Chairman, the heads of the department and all the faculties and students of School of Engineering for the webinar on Virtual Labs. So today I'll be giving you an intro on virtual labs and we'll be showing you some of the labs from electronics and communication domain as well as in electrical engineering. So I'll stop my video and I'll start my presentation. Hope my screen is visible and hope you are aware of virtual labs.
Sure, ma'am. Sure, ma'am.
So virtual lab is an MOE Government of India initiative under National Mission on Education through Information and Communication Technologies. So there are various initiatives under this program. So they are Swayam Prabha, Virtual Labs, E-Yantra and so on. So virtual lab is one among them. And the virtual lab had been started long years back and the process is still going on. So what is the motivation behind the virtual lab? We all have experienced corona days, right? So those time we were not allowed to go to a physical laboratory. So here in the virtual laboratory, the physical distances and the limit doing an experiment is not a matter. And also the equipments which we are using in the physical laboratory is of high cost. And next is the quality labs or proliferation of quality labs. So these are the main motivation behind the virtual laboratory. So the basic idea of the virtual lab is to provide remote access to n number of users and which will be located remotely. So when I say a virtual lab, it's a 3P lab. That is, virtual lab is independent of pace, place and period. So there is no time restriction or no requirement of physical lab. One can be anywhere, even while traveling, he or she can use the virtual lab. So pace in the sense speed. So some of you or your friends will be completing the given experiments within the given time, but some might not be. So here in the virtual lab, you can take your own time to do the simulation from wherever you go. So the salient features of virtual lab include remote access to labs in various disciplines of science and engineering and anytime, anywhere lab. Also, the virtual lab are free to use or free of cost. So if you have an internet connection with you, you will be able to access the virtual lab from anywhere you want. So it's accessible through internet on any PC, laptop or mobile and is developed in self-learning mode. So based on scalability to closer to reality, the virtual labs are classified as modeling or simulation based virtual labs, measurement based virtual labs, and the third one is the remote triggered virtual labs. So the first classification is modeling or simulation based virtual labs, in which the experiments are modeled using mathematical equations. And the second classification is the measurement based virtual lab, in which the experiments are conducted priorly and the data is stored. And the third type is the remote triggered virtual lab, in which the experiments are triggered remotely. So here in NITK, we mainly have two remote triggered virtual lab. One is vibration lab and the other one is strength of material lab. So when you click on to rtlabs.ac.in in NITK, you will be able to find our remote record virtual laboratory. So when I compare the physical lab and the virtual lab, we know that the physical labs are the best for user experience, but as a second best solution, we have virtual lab. And the cost involved in the physical lab, we know that we will be using equipments which are of high cost. So the cost involved in the physical laboratory is typically in few lakh rupees. But in virtual laboratory, the cost involved is almost nil or zero. And the virtual lab is designed for 24 by 7 usage, whereas in physical laboratory, we will be having specified time like college timing from 9 to 5 or 1 or 2 hour lab sessions. So which is limited in time and space. Virtual lab provides wider and safer options for innovative experimentations, whereas physical lab provides limited options for innovation. So here we had given 9 disciplines which include 7 engineering domain and 2 basic science domain. So these are the broad areas for which the virtual lab are available of. Next, it's the participating institute. So under the virtual lab, we mainly have 11 participating institute which include 6 IIT, 1 IIIT Hyderabad, Amrita University, Dalbag University, NITK Surathkal and COE Pune. So NITK Surathkal is the only NIT among all the participating institute. And NITK Surathkal is the parenting institute of MAM School of Engineering. So while visiting National Institute of Technology Karnataka Surathkal, you can also visit to Center for System Design, where all the events related to virtual lab are conducted here in Center for System Design. So Center for System Design is a place where different people from different domain work together for a meaningful engineering system. And it is also a transdisciplinary center for R&D, and the key projects are data acquisition, iris, 3D printing and laser cutting, media production, aerial photography and visualization, PSE or industry consultancy projects, and E-Entra. And the Center for System Design is headed by Dr. K.V. Gangadharan, who is a professor in the Department of Mechanical Engineering. And the lab is coordinated by Dr. Prithviraj Umesh, who is an assistant professor in the Department of Water Resources and Ocean Engineering. So faculties, research scholars, project fellows, interns and students support these projects. So Center for System Design is a center of excellence at NITK Surathkal, and at CSD we do engineering and not just read engineering. So the main projects involved in Center for System Design are UAV and ROV technologies, sound and vibrations, smart material applications, experiential learning, and so on. So here in the virtual lab at NITK Surathkal, we mainly have 400 plus nodal centers and mainly focuses on the development of labs in mechanical engineering, civil engineering, chemical and electrical engineering. So for all the updates related to virtual lab and Center for System Design, you can follow us on our social handles. So our account in Facebook are csd.nitk or sol.nitk, and in Instagram csd_nitk or sol.nitk. Apart from this, we also have a YouTube channel named Center for System Design NITK Surathkal. So you can just check on that for all the updates related to virtual lab and Center for System Design. So Lakupata, it's an initiative by Center for System Design NITK Surathkal, which is a short and apt video tutorial to encourage the user to use the virtual lab to continue the learning activities. So that's all on the introduction on virtual lab. Next, I'll be taking you to the virtual lab website. So vlab.co.in is the link to access to the virtual lab website. You can note it down, vlab.co.in. So as I already told, it's an initiative of Ministry of Education under the National Mission on Education through ICT. So virtual lab is a website, not a software, and there is no requirement of password or username to log into the virtual lab website. So moving down, you will be able to find the objectives related to the virtual lab. Repeating again, it's to provide remote access to simulation based labs in various disciplines of science and engineering. And it's a 3P lab. That is, virtual lab is independent of pace, place, and period. So moving down, we have all the broad areas of virtual lab, which include 7 engineering domain and 2 basic science domains. So moving down, you can find all the participating institute logo. So clicking on each institute logo, you will be able to find all the virtual labs developed by the institute. So these are the virtual labs developed by NITK Surathkal. So moving back. Yeah. So today I'll be taking you to some of the labs from electronics and communication domain. So when I click on to the electronics and communication domain, it will be directed you to the next page, which in which this page will be dedicated for electronics and communication domain. So here we mainly have so many labs under electronics and communication domain, and the institute who developed this lab will be given. So here in electronics and communication, we mainly have analog electronics lab, basic electronics lab, digital application, digital electronics circuits lab, digital electronics lab 1 and 2, and so on. So today, first I'll be taking you to the basic electronics lab, which is developed by IIT Kharagpur. So clicking on the basic electronics lab, which is an older lab, you will be able to find an introduction of the virtual lab will be given here. Under the list of experiments, all the names of the experiment under this laboratory will be given. So next is the instruction. Instruction of the browsers are given under instruction part, and the technology used. So JavaScript and HTML5 are the technology used to develop this basic electronics laboratory, and the people who are involved in developing this lab will be given. So if you have any query regarding this lab and the experiment, you can directly contact these people. And finally, the feedback. So you can provide your feedback over here. So under the list of experiments, today I'll be selecting the 4th experiment, which is Ohm's law. So when you click on to an experiment, you will be able to find the theory of the experiment, and the procedure to do the simulation will be given under the procedure part. So for this experiment, I have to set the resistance value first, then I have to select the DC voltage. You will be able to find here the voltmeter is placed parallel to the resistor and ammeter is placed in series with the resistor. So setting the resistance value, I can change the DC voltage value. So for each DC voltage, you will be able to get the voltmeter and ammeter reading. So after getting 5 to 6 voltmeter and ammeter reading, you can plot the VI graph by clicking onto the plot button. And finally, you can print the whole page. So moving on to the simulation part, I have different verification of Ohm's law given here. I'll be selecting the first one. So this is the simulator. Yeah, thank you. So this is the simulator interface of Ohm's law. I have the instruction to do the simulation given here, controls, an experimental table, and an area to plot the graph. So looking onto the instruction, I'll be setting the resistance value, then the DC voltage, click add to table button. So here you will be able to find the voltmeter and the ammeter reading. So keeping the resistance value constant as per the instruction, I'll be taking another set of DC voltage, click add to table. So you'll get the second value of voltmeter and ammeter reading. So keeping the resistance value constant, I'll take around 5 to 6 value of DC voltage. I'll be changing the DC voltage and you will be able to get the voltmeter and ammeter reading. So finally, clicking onto the plot button, you will be able to get the VI graph for the given values, and you can click onto the print button to print the whole page, or you can save it as the PDF for the future reference. So to clear all these value, click on to the clear button. So moving back to the main page, we will be having quiz where you have to test your knowledge. You will be a MCQ questions. You can just click your answers and you can submit the answers here. So which will be giving you the right and wrong answers. So for all the newer labs, you will be getting a pre-test and a post-test question. As this basic electronics virtual laboratory is an older lab, you will be getting a quiz and an assignment part. So assignment is also some questions related to the this experiment and the labs. So finally, the references or the resources used to develop the lab will be given under the references part. So that's all about this experiment under basic electronics virtual laboratory. We have other experiments also here in the basic electronics lab under IIT Kharagpur. So you can explore those. Moving back, I'll be taking you to the digital electronics lab developed by IIT Roorkee. So this is a newer lab. So for all the new labs, you will be able to find the contents like an introduction of the lab will be given. Objective of the lab is given here. Under the list of experiment, all the names of the experiments are given. And next is the target audience, or for whom the lab is applicable for will be given under the target audience. So this lab is applicable for BTech or BE in electronics and communication and MS or PhD beginners in EC and the related topics. And under the course alignment, the syllabi used to develop the lab and the experiments will be given. So this lab is the syllabi of this lab aligns to the following universities in India. And finally, the feedback. So you can provide your feedback, which will make the virtual lab better for you and for others. So under the list of experiments, I'll be selecting the first experiment. So selecting each experiment, you will be getting the aim of the experiment. Theory related to the experiment will be given. So for this experiment, you will be able to find all the logic gates, the truth table, symbol, etc. will be given under the theory part. So next is pre-test, some set of MCQ question where you have to click your answers and you have to submit the quiz. So all the wrong answers will be marked in the same color. So if you click the right answer, you will be getting the correct answer in the same color, or if it is wrong, it will be marked in the red color. So under the procedure part, for this experiment, you will be getting two simulator 1 and simulator 2. So for simulator 1, first you have to connect the supply to the circuit. Then you can press the switches input A and B. And if both the switches are on, you will be able to find the bulb starts to glow. And on to simulator 2, we will be getting an AND gate. We have to enter the Boolean input A and B and the corresponding output for our Boolean input. Then you can click onto the check button to verify our output, and finally you can click onto the print button to print the whole page. Sorry. So under the simulation, we have a simulation of different logic gates. I'll be selecting the simulation of AND gate. So as told here in the procedure part, we have two simulator 1 and simulator 2. So this is simulator 1. I have the instruction to do the simulation here, circuit diagram and all the specifications. So looking onto the instruction, within a single click, the battery will be connected. So here you will find a message pop up as connected. So I'll be clicking onto the switch 1. So the battery is connected to the circuit. You will be able to find the red color change to green color, which indicates the battery is connected to the circuit. So switch 2 for input A and switch 3 for input B. So when I on both the switches, now you can find the bulb starts to glow. So that's on simulator 1. Moving on to the simulator 2, as told in the procedure part, we have the instruction to do the simulation given here. We have an AND gate, a truth table and a reset button. So I'll be giving the input, Boolean input and the corresponding output for my Boolean input, and I'll click onto the check button to check whether it's right or wrong. So here in the truth table, you will be able to find the input, output and the remark. So if I had given the output as wrong, you will be getting the remark as incorrect. So I'll select all the input and Boolean input and output, and finally, if you need to print the whole page, click onto the print button given here, or you can save it as PDF for the future reference. And if you need to reset the input and output value, click on to the reset button given here, so you can find the input and output value reset here. So that's about the simulator 2. Moving back, next we have some post test, like some set of MCQ questions. You can click your answers and submit the quiz, which will be giving you the right and wrong answers. So under the references, you will be getting the references and the resources which is used to develop this experiment and the lab. Finally, the feedback. So you can provide your feedback over here, which will be helpful for us to make it better for you and for others. So that's all about the this experiment, and there are many more experiments under digital electronics lab as well. So I request you to explore all the other labs, and that's all from my end. And thank you all, and over to you, Shrestha.
Thank you, Ismail. So, very good morning to one and all present are here. Myself, Shrestha, working here as Senior Research Fellow at Center for System Design and NITK, Surathkal. So, let me share my screen now. Hope my screen is visible and my voice is clearly audible. Okay. So, Vismaya had already briefed you about exactly is this virtual lab, and also have taken you through few of the virtual labs and experiments available. Right? So let me now take you with few more labs available across the virtual labs platform. So some of the important points here, we know some concepts are common between different domains, right? Say for example, concepts of logic design or digital electronics. It is common between circuit and IT domain. So Vismaya has shown you one of the labs based on digital electronic concept. So if you see the lab listings, say for example under electronics and communication domain, there are many labs with the concepts of digital electronics available. Okay, so we have around 6 to 7 digital electronic concept based labs here under electronics and communication domain developed by different participating institutions. So some of the experiments might be available under multiple labs. Okay, so you need to explore each of the different lab available and see which user interface would be more suitable to you, and then you can utilize it as per your requirement. And also, since some of the concepts are common between different domains, here it might be available, say if you are from circuit domain, concept relevant to your domain might be available under some other related domain as well. So if you are from circuit domain, say for example, you need to look into relative domain labs and experiments as well. Okay, so when we are from circuit, we need to look into electronics and communication, computer science and engineering, electrical engineering, and physical sciences domain. So one example for that as such, I would like to take you through. So let us now get into computer science and engineering. Okay, so as I told, here as well we have many labs with the experiments relevant to circuit domain as well. To name a few, we have few experiments under computer architecture and organization lab. Then we have image processing lab, natural language processing lab. So these are some of the labs relevant to circuit domain as well. So let us now get into computer architecture and organization lab, one of the older lab developed by IIT Kharagpur. It again has some of the experiments relating to digital electronics. So other subsections would be similar to what you had seen in previous labs. Okay, so let's not get into each of the sections now. You can explore on your own. So going directly into the experiment tab, here we have these around 10 to 12 experiments being listed. Okay, mainly based on logic design concepts and memory designs. So K-map, you all would be familiar with, right? So let's get into the experiment K-map, and we need to make a note. K-map experiment is available only in the Computer Architecture and Organization Lab in this Virtual Labs platform. Now, if you tell I'll look into the labs only that are available under electronics and communication or electrical engineering, you might miss this experiment. So, getting into the experiment, again, subsections are similar. We have complete theory behind the concept, then objectives, procedure to perform the experiment in this virtual labs platform, then the experiment, simulator, this section, set of questions, okay, reference links, and the feedback. So here quiz section questions are yet to be updated. So we'll directly go to the simulator. So to open the simulator, we can either click here or directly click on this blue screen. And this is how K-map simulator is available across this virtual labs platform. So here, what are the different steps or what are the different things we can look into? First is we need to select the number of input variables. We need to decide how many cells K-map is required or how many variable K-map. So if you want a 6 variable K-map, you can select the number of input variables as 6. Okay. Then say for example, if you are given with an assignment question to solve a K-map, then you can enter each of the cell values manually. Okay, by clicking in on the cell. Say if I want to get 1 here, I need to click once. If I need to have don't care in any of my cell, then I can first enable this don't care as, and now I can get don't care by clicking twice on any of the cell. Okay, so this is how we can get one and don't care manually on each of the cell. Now, like this we can proceed. Before moving ahead, we have one more option to hide the result. So we can hide the result initially, we can make hide result as yes. Now we can enter each of the cell values manually as per the question provided. Then we can solve this using pen and paper. We can get the reduced expression. Once we complete solving the K-map and once we get the expression, next we can finally check if the obtained result is matching with the expected one by unhiding the result. Hope it is clear. Yeah, first you can hide the result, solve it using pen and paper, and then unhide the result and verify if you have obtained the answer as expected. Now, if you just want to try out K-map, then there is option to take a random example and try. Again, I can hide the result. I can reset all values to 0. I can take a random example, solve it using pen and paper, verify the result. Likewise, I can get number of input variables from 1 to 8. I can select any one number out of this and I can get the K-maps accordingly. Hope this K-map simulator interface is clear. So this
Thank
is
you, sir.
one of So this is one of the experiment available under Computer Architecture and Organization Lab, relevant to circuit domain, available under other domain lab. Okay, likewise you have many other experiments which you can explore on your own. So here as well we have ALU, then Kuhn-McCluskey algorithm, experiments on flip-flops, registers, multipliers and all. So you can explore each of the experiment. So we'll go back to the main website now and we will go one step back. Now let's get back into electronics and communication domain. Other than the labs for digital electronics, we have a lab basic electronics with the concepts relevant mostly which you study in your first year. Okay, then we have analog signals network and measurement lab where you'll be studying some of the theorem based experiments, theorem as well as measurement based experiments, and then analog electronics lab. So let's now get into analog electronics lab. This is one of the newer lab. Now here again subsections are similar. We have introduction for the lab, objective, list of experiments. Here we have 7 experiments available. Then target audience section, course alignment, syllabus mapping, and the feedback link. So we'll go to the list of experiments. We'll take one of the experiment, say log and anti-log amplifiers. Again, for an experiment, other subsections are similar. So we'll directly move to the simulation to avoid time wastage. So here we'll select one of them. I'll go with the log amplifier. If you observe the simulator interface, it is slightly different than what you had seen previously. So in previous simulators, circuits were fixed, right? You just need to provide input and note down the output variations. That is mainly for understanding purpose. Whereas we have certain labs with experiments having this kind of interface where we have components in place. First, we need to connect all the components as per the instruction and then proceed with the experiment. This gives more hands-on to the experience to the user. So here we have log amplifier circuit. We have all the components in place but not yet connected. We have node names given in blue color, and in the instruction section we have instruction to make the connection. So first we need to connect all the components as per the instruction. So L1 to L3, then L4 to L7, L5 to L7 connecting the feedback diode, L6 to L9, L9 to L10 connecting output to the display, finally the ground connections, L8 to L12, L12 to L11. So now connection is complete. Next step is to set input value, input voltage to 1 volt. Here we have a slider to select input voltage, but now it is disabled. How to enable it? So here, whichever experiment which involves flow of this type, where we need to connect the components manually, next step would be to check if the connections are right. Okay, though it is not mentioned in the instruction. So here we have check button and reset button. So we can click the check button and see if the connections are right. I got a pop-up message stating right connection. So I'll proceed. Now the select input voltage slider is enabled. Now we can continue with the instruction provided. Select input voltage, calculate the output voltage, note down the reading, input output reading. Vary the input in steps. For each of the input value, calculate the output and note down input output readings. Once you have sufficient readings in the experimental table, you will be getting the graph. So I'll start with the minimum. calculate, add to table. You can see table getting updated. So if you see, we got graph as well in the graph area. Okay, so finally we have a button called print. Clicking on that, we can see entire simulation interface in PDF format and keep for our future references. We can allow the date and time as well to display in the snapshot, and we can see it in PDF format. This can be asked as part of submissions as well. Okay, so this is one type of simulator flow available across this virtual labs platform, especially for circuit domain labs and experiments. So you can explore other experiments of this lab. We will go back. And one more variation is, as I told, analog signals network and measurement lab. Here as well, we have large number of experiments available. It is one of the older lab developed by IIT Kharagpur. So you can see different theorem experiments are available here. Signal based experiments and measurement based experiments are also available. Let's take one of the experiment. Okay, I'll just show you how the flow is. So we have other subsections as what we have seen in earlier experiments, this section and the reference links. Going back to the simulator, this is how the simulator interface looks like. You need not worry, the circuit is same as what given in the theory section. Okay. Now here again the circuit is fixed. We have procedure available within the simulator. We have different cases to provide input. We have observation table as well. Now we have two switches S1 and S2. It is to control supply and load to the circuit. So case 1 is to solve this circuit in a normal circuit solving procedure. Case 2 and case 3 goes with Thevenin's theorem. Okay, so as per the different cases, control or enable the switch as required. So in case 1, we need to connect power and load to the circuit. I'll be connecting both. So I'll make S1 and S2 as power and load respectively, and now I need to click the simulate button to get the load current. Now I'll move to case 2a. This is again a simple experiment available mainly for understanding purpose. Now case 2a is to find Thevenin voltage and case 2b is to find Thevenin resistance. To find Thevenin voltage, we know from the theorem we need to remove the load, right? So I'll make S2 as intermediate and I need to click the simulate button to get Thevenin voltage. Similarly, case 2b is to find Thevenin resistance, and we know to find Thevenin resistance we need to short the supply. So I'll make S1 as short and making S2 as power. If I click on the simulate button, I got Thevenin resistance value. Now I have VTH and RTH value. Directly clicking on simulate button will give me load current using Thevenin's theorem. Now next step, final step is to check if the connections, if the current obtained without using and using Thevenin's theorem, if they are matching. So for that, we need to click fill data to the table. You can see observation table being updated with the first set of observation. Okay, so this is first set of observation obtained for these R and voltage values. We can get other observation sets by varying R and V values. So we have up down arrows to vary each of the component value. If not, I can enter manually as well. Okay, so here circuit is fixed, but with the same experiment, we can create 60 different questions by changing each of the component values. Okay. So this is experiment or user interface with respect to Thevenin's theorem. Some of the experiments in this particular lab as well follow similar flow with the user interface. You can explore the other experiments on your own. So these are few of the additional labs available which are relevant for both the or circuit domains in general. Then as I told, we have some labs with some experiments available relevant to circuit domain under physical sciences domain as well, which you can explore on your own. So with this, I'll stop presentation from my end and hand over the presentation to the next presenter, me. Thank you. Over to you.
Hello everyone. I hope you can hear me fine.
Yes.
So I'm from electrical domain, so I will walk you through a few experiments from electrical engineering side. So first we'll go to broad area of electrical engineering, and in here we can see that all the labs and the participating institutes that is maintaining the lab. So we'll start with a very simple experiment from electrical machines lab that we have all the electrical students have done this experiment. Most of the experiments in this lab. So electrical machines lab and some introduction is given. Uh, Objective of the experiments given. List of experiments. These 8 experiments are available in this lab by College of Engineering Pune. Target audience, course alignment is given, and a feedback session is also there. If you encounter some bugs or problems with the experiment, you can use this feedback session and it will be helpful for us. So from the list of experiments, I will take no load test on three-phase induction motor, and let's see how this experiment is done. We have all done this experiment in our machines lab. Aim is given. Theory related to the experiment is given here. There is a pre-test session where you can test your knowledge, and then procedure session comes. So the procedure to do the experiment is clearly written here. We just need to read this and understand and go to the simulations. So this is the simulation page. Here you can drag this experiment from here and drop it here. And this is the experiment, and yeah, it looks familiar for us. We have an auto transformer here, a three-phase switch here, and voltmeter, ammeter, watt meters are here. We have a tachometer as well for measuring the speed or RPM. Motor ratings are given here. So according to the procedure, you just need to turn on the switch by clicking on the switch. Then you have to adjust the auto transformer, and we can see that the voltage and current and all the other energy readings are changing. So speed is still 0. That is because 34 volt, this is not enough to start the motor, so we'll keep increasing the speed until the motor starts to run. By pressing on this auto transformer, this button, we can keep increasing the speed, and now we we are getting 1400 around speed. So in order to do the no load test, we can store the data by clicking the start storing data, and it will just save this one particular set of data that is here, just like we record it in our lab record. So one set of data is recorded, then you take change the values and click start storing data, and another set of data will be recorded. So we need at least some 4 5 sets of data to plot the graph. So I'll store some 4 5 sets of data. Now we have these many sets of data. So now we can choose which plot we want. I'll choose this speed versus voltage graph. Then if you generate the graph, you will if you click on generate graph, you will get this graph plotted here. So this is exactly same as how we do the experiment in lab. So that is the procedure for doing experiment in this particular experiment. Then so another electrical machines lab is here from IIT Roorkee. So it covers some of the same experiments, but since it is developed by a different institution, it is having a slightly different structure of simulation and all. This structure is same here. We have introduction, objective, list of experiments, target audience, course alignment and all. So if I go to this experiment, speed control of DC motor by armature resistance control. This experiment we have all done. So here theory, pretest, procedure, simulation, post-test are there. So if I go to the simulation, this is the simulation of this particular experiment. So we can see that here the wiring is not done. We have to do the wiring. We can check the instructions here, and they will give the exact wiring details that we need to follow here. Then we can wire like this, connect like this, make all the wiring, and we can adjust this auto transformer here and take the reading. So that is how we after making the connection, we can move this bar here, and we can take the reading same as in the last step. We can click add to table, then we can use this create graph for making the graph of the experiment. So this, if you look at this, this has a slightly different implementation than the experiment what we did last time. So you can try this out by making the connections and adjusting the values. Now if we look here, some of the experiments that is related to electrical engineering are in other broad area as well. So for example, if we go to this electronics and communication broad area, we can find this lab. This is an example. So from this lab from IIT Kharagpur, analog signals network and measurements lab. So if you go into that, this also has a slightly different implementation of the lab. So we have an introduction here and a list of experiments here. So this lab contains all these experiments. Lot of experiments are here in this lab. Then feedback session and the people session are there. These are the developers of and maintaining people of the lab. So if you go to this list of experiments, we might find this 3-phase power measurement, which is an experiment that we have all done in electrical engineering syllabus. So if I go to this experiment, we can see that the theory, it starts with the theory section. So this is a three-phase power measurement by 2 wattmeter method. So here in this theory, they are explaining how 2 wattmeter will give the three-phase power according to the theoretical formulations and all. Then there is procedure. They have clearly given the procedure which we can refer for doing the simulation. So if I will directly go to the simulation and try to uh, see how it functions. So click here to perform the experiment. This is the simulator for this experiment, and it looks slightly different compared to the other two labs we checked in electrical now. So the procedure here is we have unbalanced and balanced load options. If we have unbalanced load, we can change each of this load individually for 3 of the phases. Or if we are having balanced load, we can change the load here, and it will change all the 3 loads simultaneously. So these connections are familiar for us. So if we turn on the supply, we will get these 2 wattmeter readings and these readings. Then we can add these to the table by clicking fill the table. Now we can change the load or change the voltage and try the experiment again. We'll get another set of readings. So like this, we can take however sets of readings we want. So from this experiment, we can conclude that this experiment is used to demonstrate that using 2 wattmeters, we can measure 3-phase power in that going on these 3 lines. So here, calculated power from 2 wattmeters is this, and measured power from the 2 wattmeters is this. So we can see that they are like similar, they are very similar, they align very properly. So that that is an indication that this theory that they have given here is true, and this is the experiment is a demonstration of this theory, which says that we can measure 3-phase power using 2 wattmeter. There is also a quiz session. So if you start the quiz, you will get these questions which you can submit and check how much, if it is correct or wrong. So it will be shown here with these tick marks and these X marks. So references to learn more about this experiment is also given here. Video lecture from NPTEL is also linked here. So sometimes we will find the experiment that's related to our domain, maybe in some other broad areas. So this experiment is an example of that. Then if you go to electrical engineering labs developed by NITK Surathkal, these 2 labs are here: substation automation and industrial electric drives lab. So depending on whether it's in your syllabus, you can check this out. It mainly deals with PLC ladder logic programmings and applications of PLC. It's given here the objective, introduction. If you go to list of experiments, these many experiments are here in this lab. Then target audience, course alignment, feedback. So from list of experiments, I'll just show the working of this experiment. This experiment is used to control the direction of the motor. It's used probably for an industrial application. We want to run the motor in 2 directions. So how we can implement that using a PLC ladder logic? That is what is demonstrated in this experiment. So aim, theory. In theory, they have given introduction to ladder logic and how ladder logic works. So it's a detailed theory part. Then procedure is here. Procedure also they have given very detailed, which you can refer while doing the experiment. Then like pre-test, there is this self-evaluation session, which is a quiz which we can use to test our knowledge. Then comes the simulation. So here the simulation, in the simulation we can see the ladder logic of the PLC here, and it is simulated in a way how motors work in industrial settings. So if you click this forward push button, it will start running in forward, and if you stop this now, see this accumulator here is counting till 10 and the motor is still rotating, which indicates the inertia of the motor. So most often the motor will run for some time before stopping, and if you have to reverse the motor or stop the motor, we have to wait till this is done, then we need to we can reverse the direction. So that is the simulation of this experiment, and if you stop, you can see that the motor is running till this accumulator part is completed. So you can check the uh, procedure and theory, and you can play around with this simulation, and it will be helpful to learn about PLCs from these experiments. And here there is an assignment section is there, quiz session is there, and videos related to controlling the experiment is here, references to learn further, feedback session. So that is the experiment of PLC from NITK, and substation automation lab is also there from NITK. It has all these experiments. If it aligns with your syllabus, you can try going through that. It will be very helpful. So from electrical domain, these are the labs and these are the experiments that we have. So with that, I will finish the demo, and I will hand over the session to the next person.
That's all from our end, sir. If you have the participants have any query, they can ask right now.
Students, if you have any query, please be asked to the team. And if students need any login ID passwords, if it is possible, directly they are login the virtual lab.
No requirement of password or username, sir. Anyone can log in at any time using vlab.co.in ID, like login ID. It's a
Okay,
link to log into the virtual lab website.
okay. Thank you. If anybody any queries, please be asked them. Okay, ma'am. Okay, it's any. So Dinesh Kumar, you raise your hands. Maybe ask any question. Okay, it's a time to the for the vote of thanks for the virtual lab team. Once again, it's a wonderful opportunity to do the virtual lab introduction session for our institution, School of Engineering. I thanked our management, respected principal, and various department HODs and my students. And I gratitude my once again my thanks to our NIT virtual team for the wonderful support to organize the online workshop. In future, we will conduct the many of the sessions for the civil and mechanical engineering. So I thank to our virtual lab team. Very thank you, ma'am. Once again, I thank to our management. Thank you to all.
Yeah, so thank you, sir. Thank you for giving an opportunity on behalf of the virtual lab team. Thank you, Principal, sir, Nodal Center Coordinator, heads of the department, and faculties and students of School of Engineering for listening us. And I request everyone to explore the resource and introduce to others as well. So if you have any query, you can write to us at solve@nitk.edu.in. We'll be happy to help you. So that's all from our end. So thank you all, and we request you to explore the resources. Thank you all. All the best.
Thank you. So shall I wind up the session? Thank you to all.